So now we are in unit 4 or about momentum. This is our first question with regard to momentum. So if you have studied the unit, basically we'll know that the impulse is equal to the change in momentum. And when the forces vary during that impulsive period, basically we can find that impulse is in the graph or the area under curve in the F and T graph, right? So the F varies in the T graph. Basically this area is going to give us the impulse, and this impulse is equal to our change in momentum. Okay, change in momentum. Okay, so if you know this basically you know this question will be pretty straightforward, and we'll be able to get to the answer very quickly. So let's start. A time varying force varies with time, right? So it's a variable force. The force acts on a body of mass 4 kg, so m is given to be 4. So I'm going to just write it down, right? And then there's a graph is given. Find the impulse of the force from t equal to 0 to t equal to 15. That's pretty straightforward, right? In a force and time graph, all we need to do is to find the area, right? So we're going to find this area, and that is going to be equal to our impulse. Okay. So let's find this area. This has 3 parts. First is a triangle. Okay. So that's going to be half into base is 5 into the height is 8. Okay. So that's triangle done. Then we have here a rectangle. So this looks like 10, 12. So this is 12. Okay. So it has a width which is going to be 12 minus 5. That's going to be 7 into the height, which is going to be 8. That's rectangle. And then we again have a triangle. So we're going to do half into the base. So it's 12. So 15 minus 12 is going to be 3. And the height is going to be 8. And this is what is going to be our impulse, right? Newton seconds. So let's find that. So 5, 4, 20. Okay. And then 56. And then 12. Okay. Let's check. We have done it correctly. 20. 56. And then it is going to cut, and it's going to be 12. Okay. And this is going to be equal to how much? 56 plus 20 plus 12, and that will be 88 Newton second. Okay. And that is going to be our impulse for the part A is done. Now, in the part B, find the speed of the mass at 15 seconds. Assume the initial velocity was 0. Okay. So as we know, this impulse of 88 is going to be also equal to the change in momentum. Okay. That is going to be mass into the final velocity minus mass into the initial velocity. Because the initial velocity is 0, this is going to be simply mass into velocity final. Okay. So with that, our this 88 is going to be mass into the final velocity, and the final velocity is going to be 88 by mass, and mass I think is given. We noted it down. That's 4 kgs. So this is going to be 88 divided by 4, and that's going to be equal to 22 meter per second. Okay, that's pretty easy, right? So if you know the impulse momentum theorem, that impulse is equal to change in the momentum. Basically, you should be able to do this pretty easily. Now part C, state the initial velocity of the body so that it is brought to rest at 15 seconds. Okay. So if we do the other way around, it is saying, what will be the initial velocity of the body? So it is brought to the rest at 15 seconds. So in this case, my V final is going to be equal to 0, and the initial velocity has to be there, right? So that my final impulse is going to stop this, right? So again, which means in the other way around, my initial velocity has to be equal to what we have been given here, right? What we computed actually, right? Which is 22 meter per second. So the object is starting with 22 meter per second, right? The impulse is acting in the other direction, right? And comes to the 0 meter per second. My change in momentum again, right, is going to be equal to 88, correct? And that is going to be the impulse mass into the V initial. So we substitute it back, basically we get 22 meter per second, and that will be our answer for this, right? So this is a simple application of impulse momentum theorem. So if you just know that by the area we can find the impulse, it's just a matter of doing the calculation and then going to make it equal to the momentum or change in momentum. Basically, we can find the initial and final velocities just like that.